Yes. Hope everyone is fine. Welcome back. We start our chapter 15, probability. Last year you have studied probability. Probability means it is the study of chances. It is a science of chances. That is, it can happen. It may occur. Like that telling means it is about the probability. There are certain terms related with the probability. Before going detailedly into probability, certain terms you have to understand related to probability. Among that one, the first one is a random experiment. We know in science means hydrogen and oxygen combine together. When hydrogen and oxygen react together, what will get? We get water. So in the world, wherever that reaction take place, hydrogen and reaction between hydrogen and oxygen take place, we get water. We can tell the result, what will happen. Or when carbon burns in oxygen, what will get? We get carbon dioxide. Yes, that means we can predict or we can tell what will be the result of the reaction. But here in probability we take certain activities or the reactions or the experiments activities. Though we know the result, we cannot predict the exact result of the experiment. Did not get it? We know what will be the result, but we cannot predict the result. Such experiments are known as a random experiment. So what do you mean by random experiment? Means an experiment in which all possible outcomes are known. We know the possible outcomes, but the outcome cannot be predicted in advance is called a random experiment. Means, just for example, tossing a coin, very common one. Coin tossing. We know what will happen. What will get it? Yeah, we get either a head or a tail. But when you toss a coin, we cannot tell this will happen, this will occur, head will get. Can we tell? No, we can tell, but it may not occur there. The outcomes we know, the result we know, but we cannot predict the exact result. Such experiments are known as a random experiment. Clear? So some examples for random experiments. One I already told. What is that one? Tossing of coin. When we toss the coin, the outcomes we know. Which are the chances there? Head or tail we get. We know either head or tail will get, but we cannot predict it. Another one example, very common example, what we can use is throwing a die. Die means which we use for playing a snake and ladder, ludo, etc. So when you throw a die, which are the outcomes, which are the possible chances, the number which is coming or the number of dots which is coming on the upper face, that we called the result there. So which are the possible outcomes there? Yeah, either we get 1, 2, 3, 4, 5 or 6, maximum up to 6. We can get any one of these numbers, we can get it. The result will be any one of these 6 numbers, 1, 2, 3, 4, 5, 6. But we cannot predict this will get 1 or 2 or 3 or 4 or 5 or 6 will. We cannot tell this will get. Like that, results are known as, that experiments are known as random experiment. So throwing a die is an example for random experiment. Another one example is, so examples are, one is tossing a coin. The possible outcomes are, which are the possible outcomes? Head or tail. And throwing a die means which is a possible outcome. Which are the possible outcomes there? 1, 2, 3. The numbers 1, 2, 3, 4, 5, 6. So how many possible outcomes are there in tossing a coin? In tossing a coin, 2 possible outcomes are there, either head or tail. These outcomes, the outcomes of a random experiment, that is known as sample space. Last year you studied it. So which are the sample space for tossing a coin? Head or tail is the sample space for tossing a coin. Thus, possible outcomes of a random experiment are known as, the collection of possible outcomes is known as sample space. And another one is throwing a die. Which are the possible outcomes? 1, 2, 3, 4, 5, 6. That are the possible, that is the samples. Another one example is what is called die, play, taking a card from the playing group of playing cards. You know, some of you are playing cards in mobile, also you are playing cards. How many cards are there in playing? That in a group of cards, in a deck of cards, there are 52 cards, and all these 52 cards are of different types. 52 cards are different altogether. How many are there? So possible outcomes, how many are there? This is also an example for random. We can tell any one of the card only will get, but we cannot predict which card will get it. Now, so how many cards are there? 52 cards are there. In that 52 cards, the numbers are, they are mainly, it is divided mainly into two groups. The numbers are written in two colors. Yeah, some are written in, which are the colors? Some are written in black, some are written in red. That is, half of the cards are written in black and half of the cards are written in black. The numbers are written, numbers or the letters are written in red or black. That means how many cards are there? 26 black cards and 26, half is 26 red cards. Okay, good. And this 26 black cards again divided into two types or two suits. The one is club. The first one is called club. Club means this one symbol. Of course, it is not placed correctly. This one is club. And the second one is, this one is spurt. And the red cards are two types, which are the diamonds and hearts. So black cards, how many are there? Two types are there, which are the clubs and spurt. The symbols are misplaced there. I'll make suitable card and will add in the description box. Okay, and diamond and heart are the two types of red cards. So red cards, two types are there, diamond and hearts. And club cards, black cards are also two types, which are the club and in Nagamese or Hindi you tell some other names, I don't know that name. And that means four types of cards are there, which are the, so mainly two types, red and black. That red is divided into two types and black is also divided into two types. That means altogether how many types of cards are there? Four types of cards are there. And each type is, how many are there? Four types means 13 cards are there. And in that 13, in each group of that 13 cards, you can find a card with a K letter or a face of a king. You can find a card with a letter Q, queen. You can find a card of J, that is jack. You can find a card with A means ace. So in all that four category, these four letters, then not number, these four letters cards are there. K means Q, king, Q means queen, and J means jack, and A means ace. And that four cards in every type. Then after that, so after 14, 4 are with the numbers K, Q, J and A. Balance how many are there? 9 cards. These 9 cards are with the numbers starting from 2, 3, 4, 5, 6, 7, 8, 9, 10. How many cards are there? 9 cards. So in every group, you can see a king, a queen, a jack, an ace, and a number of numbers with the 2 to 10. That means in club, 13 cards are there, they are different. 4 of them are with the K, Q, one is with the K, one is with the Q, one is with the J, and one is with the A, and 2 to 10 numbers. In spurred also, how many are there? 1 K, 1 Q, 1 J, 1 A, and 9 cards with the numbers. In diamond also, 1 K, 1 Q, 1 J, 1 A, and 9 cards with the numbers. And in hearts also, how many are there? 13 are there. 13 cards are different. One is K, one is Q, one is J, and one is ace, and 9 cards. That means all that 52 cards are different type. So when you take one card from there, we can get any one of this card only, but we cannot predict which card will get. So it is also an example for random experiment. Understand? These different types of cards you make it clear. Okay, some problems are based on these cards. So altogether how many? 52 cards, 26 black and 26 red, and 26 black cards are again two types, which are there, one is club and one is club spurs, and in red cards also two types are there, diamond and hearts, 13 cards, and in each group one queen, one j, one king and one ace are there, and 9 cards with the number. And among this one, this king, queen, jack and jack, when you look the card, there are some faces are printed, some faces, that not exactly faces, but the pictures like faces are printed are there. So these cards, these three types, which are the king, which are the three cards I am telling, king, queen, jack, of all the 4 category, they have some faces printed there. So they are known as what is called face cards. So face cards, which are the face cards there? King, yes, king, queen, jack of each suit are called face cards. So that means face cards altogether, how many are there? 12 are there. One king, one queen, one jack from club. Everywhere 3, 3, 3, 3, 4 are 12. 12 cards are there. Out of that 12, 6 of them are black and 6 of them are red. So these are the different types of cards present in a deck of playing cards. This chart I will make a separate one in clear way. I will make and send add in the description box. You can get it from there. Okay. Then another some terms. So which are the examples for what is called the random experiment? Throwing a tossing a coin, throwing a die, and drawing a card from a well shuffled deck of cards. Okay. Then another some terms what we need to, another one is what is called the formula, the theoretical formula. The theoretical formula to find the probability of an event. So event means when you throw a die, when you toss a die, which are the possible outcomes? Head. Head is an event. That is called event, or it is also called an outcome. The probability of finding the theoretical, not a practical one. Practically it may be different, but theoretically we can calculate or we can find out the probability of any event occurring during a random experiment using the formula. Probability is equal to number of favorable. Favorable means what we are selecting, that one, divided by total number of possible outcomes. This is the basic formula we use there. Look the formula. What is the formula? Number of favorable outcomes by total number of possible outcomes. Simply you can remember m by n. The most common mistake what we make, the total should be always downside. Okay, total should be always down. So what is the formula? Total number of favorable outcomes divided by total number of possible outcomes. Okay. Then shear event. Some terms. Shear event. An event whose probability is 1 is called shear event. Just to remember the definition, it can be asked as MCQ question. That is the probability of getting a shear event. Shear means look, when you toss a die or when you throw a die, which are the numbers we are getting? Numbers from 1 to 6. So when you calculate the probability of getting a number less than 7, all the numbers are less than 7, so we get the probability as 1. When you do the more problems, you will understand that concept more clearly. Remember, what is shear event? Shear event means an event whose probability is 1 is called shear event. An impossible event, which cannot occur, which cannot happen. The probability of an event whose probability is 0 is called an impossible. So what is the probability of a sure event? Probability of a sure event is 1 and probability of an impossible event is 0. Okay. And another one is complementary events. Means if suppose then you take tossing a coin, getting a head. Suppose if we choose an example of getting a head, getting not a head, that is they are just opposite events. When it's considered to opposite events of a random experiment, they are called as complementary event. Just opposite of what? Just opposite of one experiment, one event, that is called a complementary event. If let E be an event, then or not E, E or bar is there. On the top we give a bar. E on the top we give a bar, that is known as E complement. Is known as complement events. And probability of event and probability of its complement always will be 1. Okay, these are the, and remember, probability of an event cannot be, these 3 points you remember there. One is sure event, probability of sure event is 1. Impossible event, probability of an impossible event is 0. And probability of an event never be negative, it will be always lying with between 0 and 1. The symbol is not clear, that is why I am not telling 0, between 0 and 1. It can be 0, it can be 1, and it will be always between 1 and 0. It cannot be more than 1, it cannot be less than 1, less than 0. That means it cannot be negative, it will be always a positive number lying between 0 and 1. Okay, these are the main points. Let us start the exercise. Take the textbook, look the questions one by one. Look the first question number 5. Write the question. What is the question given there? The probability of an event E is given as 0.5. What is the probability of not E? Look, E and not E. E and not E are what type of what type of events they are? They are complement. Complement events means their probability will be always 1. Sum of their probability will be always. So we know probability of E and probability of not E is equal to 1. Clear? So probability of E is given 0.05, probability of not E is equal to 1. From there we get a probability of not E is equal to, so when equal to 0.95, subtract that one, you get a 0.95. So remember, probability of E and probability of not E, they are known as complement event, and their probability will be always 1. That concept only we use. Clear? Right answer. Okay, write the question and write the answer. Let us look the next question. Question number: a bag contains lemon flavored candies only. Maklini takes out one candy without looking into the bag. Look, only lemon flavored candy. What is the probability that she takes out an orange flavored candy? Look, in the bag or in the box, only one type of candies are there. Only lemon flavored. From the lemon flavored candy, if you take a candy, what type of candy only you will get? You will get only lemon flavored candy. Look, what is the first question? Find the probability of getting an orange flavored. Is it possible to get an orange flavored candy from a lemon from the group of a lemon flavored candy? No, it is not possible. That is called impossible event. So since the bag contains only lemon candy, so getting an orange flavored candy from the bag is an impossible event. We cannot get an orange flavored candy from the group of a lemon flavored candy. Is it clear? So that is an can we get it? Is it possible? No, it is not possible. So it is an impossible event. What is the probability of an impossible event? It is 0. So probability of getting an impossible event is, probability of getting an orange flavored candy from the group of a lemon flavored candy is how much? 0. Okay. Then what is the next one? Lemon flavored candy. Probability of getting a lemon flavored candy. Look, we have a box contain only lemon flavored. So whichever candy you take from there, it will be only lemon flavored. We get only lemon candy from there. So always lemon candy only we get. So it is a sure event. That is one sure event. The first one is impossible one. The second one is sure event. Sure event means what is the probability? The probability will be 1. So since the bag contains only lemon flavored candies, we always get a lemon flavored candy. So it is a sure event. So probability of sure event is 1. The first one is impossible, and the second one, so it is 0. The second one is sure, so the probability is 1. Okay, let us look the next question. It is given that in a group of 3 students, the probability of 2 students is not having the same birthdays. The probability is given. Probability of not having the same birthday is 0.992. Out of 3 students, 2 students not having the same birthday is 0.9. Then what is the probability of having the same birthday? Look, just look the question. What is the probability given? Probability of not having the same birthday is given. And what do you need? Probability of having the same birthday. Look, they are just opposite events only given. Opposite events means they are what type events? Complementary. Complementary events means their sum will be always, sum of the probabilities will be always 1. So probability of not having the same birthday is given. Therefore probability of having the birthday and not having the birthday is equal to 1. So probability of not having the same birthday is equal to 1 minus 0. What is given? That one. So we 0.0992. So we get the answer as 0.008. Do the subtraction correctly. Okay, 1.00 put 1 point, when you do the subtraction, 1.000, 3 zeros, then 0.0992. 0 minus 2 is not possible, so we take 1. 10 minus 2 is 8, 9 minus 9 is 0, 9 minus 9 is 0, so we get 0.008. Okay. Question number 8. Let us look at the next question. Question number 8. A bag contains 3 red balls and 5 black balls. 3 red balls. So how many red balls? 3. And how many black balls? 5. Total number of balls means total 8 balls are there. So probability of getting a red ball. So what is our formula? Number of favorable outcomes by total number of outcomes. That is our formula. Number of favorable means, what is favorable here? Red ball. How many red balls are there? Yes, 3 are there. And total how many are there? 8. So the answer is 3 by 8. M by N. M means favorable. Favorable means what we are taking. Red ball we are considering there. Red ball, how many are there? 3. By total is how much? 8. Then probability of not a red ball. Look, getting a red ball and not getting a red ball. They are complementary one. So what we can use? The complementary idea we can use it. The probability of not getting a red ball and probability of getting a red ball is equal to 1. Probability getting red ball we have how much? 3 by 8. That is 1 minus 3 by 8. Taking LCM, 1 minus 8. 1 into 8 means 8. 8 minus 3 by 8. That means 5 by 8. Getting? Okay. Then the remaining, try these questions. Question number 9, 10, 11 and 12. Same only. Similar only. You can try it. Try the questions. Ask homework. Write the notes from here. I think you can write the notes. That chart 1 I will add as a separate link there. The other one, remaining notes, you make your own notes and try the questions. Even the solutions also right there. You can pause and write the notes. Okay, and try these questions as homework. If you can, just send me through the Google Classroom. That would be better. I can correct if the homeworks, if we upload there, I can correct and send if there is mistake. Okay. We can do in the next, we can complete in the next balance exercise in the next video. Okay, stay home. Thank you. Stay home, stay safe. Okay, thank you.